Manuel and Carmine going on 2 road trips. Well, the same road trip, but in different cars. The graph here represents Manuel's road trip. The table represents Carmine's road trip. So these numbers are not these numbers. These are 2 separate functions being represented in 2 different ways, table and graph. We started this off yesterday, but just to review, we looked for the change in y from 150 to 200 is plus 50. So we could continue that plus 50 pattern all the way over to the right. And we can loop that pattern backwards by subtracting 50. Now, a lot of us went 1 space over. But if we're looking for the b value of Carmine's trip, we've got to find where x is equal to 0. So we had to go an additional 1 more space over. And we get the point 0, 0. Which means that Carmine's b is 0. The change in y is 50 over the change in x, which is 1. 50 over 1 just gives us a slope or a unit rate of 50. And we're talking about miles per hour. So that's how fast Carmine's driving on her road trip, 50 miles an hour. A little slow. She'll get there. And then we take a look at Manuel's road trip on the graph. Now this is finding slope from a graph. Anyone remember what that process is called to find slope from a graph? Rise over run. Thank you. So if we start down here at 0, right, we rise up 1 over 1. So I saw a lot of people say, oh, my slope is 1. But that means that Manuel's driving 1 mile an hour. It's going to take him a while to get wherever he's going at that speed. Even though we only rise 1 box up, how many miles are we rising up from 0 to 60? We're rising up 60. So my rise over run is 60 miles in 1 hour. 60 over 1 just gives me 60. Where's Manuel's starting point? What's my b value on this graph? 0. It's right here. It's where the y-axis intercepts the line. We see that they both converge on this single point right here, which is at 0. And that makes sense, right? Because after 0 hours, Manuel has driven 0 miles. For Carmine, after 0 hours, she has driven 0 miles. All right, so they're both starting off their trips at home. So Carmine's slope was 50 miles per hour. Manuel's slope was 60 miles per hour. Who's driving faster? Manuel. How can we tell that Manuel's driving faster? He's going 60 miles an hour? Okay, but how does that tell us he's going faster?
Because Carmine is going 50 miles an hour.
Exactly, because Carmine's only going 50. So we're comparing these 2 functions. In order for us to compare something, we need 2 things. In this case, 2 unit rates, 50 miles an hour and 60 miles an hour. Manuel's driving faster. After 7 hours of driving, who is farther from home? Now this is our evaluating functions, 6.2b. There's a couple different ways we could do this. Carmine's equation, if we write it, we could say f of x is equal to 50x plus 0. Don't need to write plus 0. Manuel's function g of x is 60x plus 0. No need to write plus 0. And we could plug in 7 for x, solve it out, and see who's gone the farther distance. So for Carmine, 50 times 7 would give me what? 350 miles. And for Manuel, 60 times 7 would give me what? 420 miles. So between Carmine and Manuel, who's driven further away from home? Manuel again. Anyone see another easier, less mathematical way to figure out who's driven further? Hope? Exactly, just look at the graph in the table. If we're taking a look at Carmine's table, at 7 hours, how many miles has she driven? 350. Is that the same mileage we found down below doing it mathematically?
Yeah.
Yes, it is. Let's look at Manuel's graph. Here's 7 hours. If we look all the way up and all the way over, he's at 420 miles. Is that what we found mathematically down here as well?
Yeah.
Yes, it is. So 2 different ways you could do it. You could use the information provided to you and figured out by you. Or you could evaluate the function at that number given to you and solve it out to figure out who's further from home. And it makes sense, right? They both started off 0 miles from home. Manuel's clearly driving faster, so naturally he'll be further away from home. All right, questions I can answer about that one? Because I know there's a lot going on there. There's a question almost exactly like that on the test. So I want to make sure there's nothing, no confusions or anything. Is that what you got for that number one? Good. Down to number 2. Now we're comparing 2 functions. No need to worry about the context of who's driving or what we're talking about here. Just comparing straight up functions. First one is f of x. It's equal to 1/3 x plus 2. And this is written in the form y is equal to mx plus b. So my slope of this function is m. What's that going to be equal to? 1/3. My y-intercept, Darius, is going to be what? 2. M and B. Nice and easy. All we got to do is use our eyeballs to look and identify what those are. Now, do we need to write the equation of this function?
Yes.
No, why not? Because that's what was given to us, right? So let's go over to g of x. G of x, I don't see a y equals mx plus b here, so we're going to have to figure this out ourselves. The slope, if we remember, is the change in y over the change in x. My change in y from 2 to 5 would be what? Plus 3. My change in x from 1 to 2 would be plus 1. 3 over 1 just gives me 3. If we continue this pattern, I'm going to zoom in here. If we continue this, what the heck? There we go. If we're going plus 3 to the right, what's my next y value going to be? 8. And if we go minus 3 to the left, negative 1 is what we get. So my b value here is wherever x is equal to 0. Whenever you see x and 0 on a table, your brain should be trained right away to say, oh, that's my y-intercept. There's my b. So what's b equal to here? Negative 1. Now when it comes to comparing, the y-intercept doesn't really matter because what we're comparing, well, I guess in a way it does. When it says to compare, we got to figure out, is f of x linear? Are there any exponents in this equation?
No.
No. So is this linear or non-linear? Linear. Is my b value equal to 0? No, it's not. So is this proportional or non-proportional? Non-proportional. Now let's take a look at g of x. Now, there's no equation for us to kind of look for exponents on or anything like that. But we could write the equation. If my slope is 3, my y-intercept is -1, we could say g of x is equal to 3x minus 1. Is there any exponents in there? Nope. So that makes this linear. Is my b value 0? No, it's not. So this is non-proportional as well. So far our comparison hasn't given us any new information. They're both linear, they're both non-proportional, but I want to know why they're different. So we got to figure out which one is steeper if we were to graph these. We don't have to graph them, thankfully. We will be doing some graphing today, but not of straight lines. So we look at our slopes. F of x slope is 1/3. G of x slope is 3. And we ask ourselves, which of those numbers is bigger? Would you rather have $3 or 1/3 of a dollar? $3. So if 3 is my bigger slope, that means that the function g of x is steeper. So the only thing we're using our b values to compare with is the proportionality. If our b value is not 0, we know it's non-proportional. If it is 0, it's proportional. The slope, though, is where we figure out which one is steeper. That's all we got to do for our comparison. Nothing crazy. Definitely want to make sure you keep this worksheet safe in preparation for our test. So you're going to have to do this exact same thing here in a couple days. Questions I can answer about that? All right, let's run it back one more time with number 3, quickly. Number 3, we got function f of x. What's my slope in f of x? 10. What's my b value? 0. Right, nothing being added on the end. Right away, we could identify this as linear because there's no exponents. Non-proportional? Is my b value 0?
Yes.
Yes, it is. This is proportional. Proportional. We take a look over to g of x now. Got to do a little bit more work again. Now, this is where I saw a lot of people make a mistake, so definitely make sure you're paying attention here because you might have made this mistake as well. What's my change in y from 0 to 3? Plus 3. So a lot of you went, okay, my slope then must be 3, but not quite. What's my change in x on the top? Minus 3. M is equal to the change in y over the change in x. Positive 3 over negative 3. What would that simplify to?
-1.
-1, thank you. So my slope here is -1. We could continue this plus 3 pattern to get 6, and we could reverse that plus 3 pattern to be a minus 3 and get what? -3. Guys got it. So my y-intercept, again, this is another mistake we made. A lot of times we just look to the far left and say, oh, my y-intercept is -3. But it's not always going to be on the left. It's wherever x is equal to 0. So what's my b value here? 6. Is this linear or nonlinear? It's going to be linear. Right? Even if you don't want to write the equation, we know that it's linear because we could find a constant change in x and a constant change in y. That means we have a slope. That means that this is linear. But is it proportional or non-proportional? Non-proportional. Now, look at the slopes between 10 and -1. Which of these lines will be steeper, f of x or g of x? F of x is steeper. How can we tell? Because 10 is larger than -1. Great job. Some of you guys got this perfectly. If not, hopefully that helped clear some things up. Hopefully it's not as difficult as we may have thought going through it yesterday. All right?